All right, good morning, everybody. Oops, no shouting. It's a pity the room doesn't have an auto-extend feature on it, because it looks like we're sort of almost running out of chairs. So, welcome everybody. Nice to see so many people bright and early after the party night. People had fun? Yep. Yeah. I won't do the American thing and go, yeah! Anyway, welcome. So, for those who don't know me already, my name's David Lyth. So, I'm a field engineer with Microsoft. So, I'm based out of Wellington, but I get to tiki-tour around most of New Zealand and talk to customers about SQL and data warehousing and a wee bit of PowerShell for my sins. So, today, we're talking about non-relational stuff in SQL Server, specifically 16. So, must admit, the title is a wee bit of clickbait in that most of the demos that we're going to do are how to use T SQL to work with the non-relational features, which is a good thing for people who, like me, are based on SQL. So, what we're going to talk about today, these are the generic what's new in SQL 16. So just out of here, on the left, we've got Polybase and our R integration, and then talking about what we're doing for JSON support in 16. And there's all those other good things, but we're not going to talk about those today. So, Daniel, the slides are being published on the website. You don't need to. So, first off, they're in no particular order. We talk about Polybase, which you will have heard various people talking about in other sessions through the week. So, what is Polybase? So, this is the ability to talk to non-SQL data stores, specifically Hadoop and our Azure Blob Store, to be able to interact with that and easily pull in data. So the idea is that you as a SQL person can quite happily write a piece of SQL code and interact with both your SQL data stored in normal tables and your non-SQL data that's sitting there, and combine those in one statement as well. So you can do a join between your Hadoop data and your SQL table. So the idea is you don't need to learn some other language, and you're also able to easily combine those two data stores. So what can you do with it? First one, load data. So for those of you who went to the Genesis Azure Data Warehouse talk yesterday, one of their mechanisms for loading data into the Azure Data Warehouse is pulling in through Polybase. So that is regarded as the fastest way to load data into an Azure Data Warehouse. So it's great for doing that. And because we've brought it into the SQL Server 16 engine, you can use the same mechanism for doing that. So the only place that you can't use Polybase is in the Azure SQL database, because that's purely a database focused offering. Doesn't have these instance level things, but SQL Server 16, Azure Data Warehouse, and the Parallel Data Warehouse, which we rebranded as APS, all have Polybase in them. So interactively query, so if you want to go away and find out what's in your Hadoop data, you can quite happily write a select star using this stuff. And we've also got the option of aging out data. So if you've got old data but you haven't been able to get any business user to sign off to say that you're allowed to delete from that table all your data older than 3 years old, you can use the Polybase connection to then write all your data out from your SQL table into an offline storage, either Blob Store or Hadoop, and just keep it there as your just-in-case storage. Obviously, the other thing that was being talked about this week is StretchDB, which is another way of archiving out data, but we like to give you lots of choices, so you can do it whichever way you like. So that's some of the things that you can do with it. So what does it actually look like? So you get a Polybase turned on your SQL Server, and then it hooks up to either a Hadoop cluster or a Blob Store. Now in the diagrams they include lots of other SQL servers, so this is for scale out if you find out that your SQL Server ends up being your bottleneck when you're doing these connections. I sort of guess that for most New Zealand implementations, that's not really going to be a thing, but it's there if you need it. So the idea with that is that if you've got one of these scale out groups, you run a select star from table name, you go down to polybase, it then shards out that query before it goes down to your Hadoop data store, and all of those shards can then run in parallel to give you faster execution time for that. So it's available. Like I say, I don't think many people locally are going to use it. You never know, someone might surprise me. So obviously, first off, for this stuff to work, you need a non-SQL data store. So you can go off and set up Hadoop cluster, and if you're like me, you go off to Azure and set up a Hadoop sandbox so you can play with it, or if you've got a real one, set it up. Or you set up Azure Blob Store. Now, one thing off that slide is that we talk about predicate pushdown a wee bit later on. Sorry. But one thing about predicate pushdown is your blob store doesn't have any compute resource associated with it. So you never get any predicate pushdown with that. So if you do a select star from Azure blob store, you always get the full result set being pulled back, and then any filtering is being done in your SQL environment. So just be aware of that. So we throw SQL Server onto your box. There is a tick box option if you're using the GUI to say, please install Polybase. And then all of the DLLs are thrown into there. So there is one prerequisite that you need to go to Oracle, our friends, and go and get the Java runtime engine, because Polybase makes use of that. So you need to do that before you start the SQL install. Otherwise you'll get the prereqs check will fail and tell you to please go away. So just be aware of that. Then you need to choose which sort of data store you're going off to. So you've got this SP configure option, which is the Hadoop connectivity, and it's got a number after it. Just be aware that number 0 is obviously disabled, but it's not just a binary 0 or 1. That's actually a number that goes up to 7. So that number is the thing that determines the dialect of Hadoop storage that you're talking to. So you can see on there we've got the supported big data sources. So that was current as of last week when I went and checked the URL that's there. So we go up to Hortonworks 2.5, and you can see that the Linux implementation has got later versions supported than Windows. Not quite sure why, but that's what's there, and Cloudera. And then Azure Blob Storage is the other supported one. So if you're looking to see what flavor of Hadoop is supported, go off to the link and see whether they've updated that. Don't rely on this as being gospel. And obviously doing that then puts the right bits in the back end to be able to talk to that particular implementation. Does mean that you can only talk to one type of big data store per instance. You can't try and talk to blob storage and Hortonworks at the same time from the same instance. And it's an instance restart to change that as well. So just be aware of that. I haven't tested it, but I think that you can have two instances on the same box, both talking to different sorts of big data store. So, and then we just attach, which we look at through code. So this is your actual, how do I do this stuff? So your first off is creating an external data source. So just give it a name. The type equals Hadoop. And then the location is just the IP address and the port number for whatever you're connecting to. Fairly basic stuff. The file format is just describing the way that the files on that data store are laid out, because obviously they're pretty much just flat files. So you've got to say, what's the delimiter, what's the date time format, all those sorts of things. And that's where you can describe that. And if you've got multiple different sets of files and they've got different configurations, you can create as many of those file formats as you want. So they're just objects that live inside your SQL database. Then finally, once you've defined those two prerequisites, then you go off and you create an external table. So this is just a piece of metadata. It's not pulling any real data in, it's just describing the external table. So in here you do all the usual things you do with a table, say all the fields and types, which hopefully you've matched with your external table to have the same fields. And you just say where it is in the Hadoop data store, so you've got to drill down through all the folders and then match it up with your data source and your file format. So fairly straightforward stuff. In queries, you can see we just created a table called sensor data, and we can just then do a select. Nothing special about the select statement. And if we've got another table that's the automobile data out of there, that's just a regular SQL table, then you can just join to it. So you don't have to do any special syntax once you've defined that external table. So just what does it look like? So we do a select star. So possibles plan. So you just create a temp table out of Hadoop, pull that stuff in, and then actually at the SQL level do the filtering. And we could do the aggregation on the external table. So in this example, the optimizer is chosen to say, hey, let's let Hadoop do some of the filtering and aggregation. And then once that's done, then we can pull that in to SQL into a temporary table. So once again, the optimizer is cost-based, and it's looking for a plan that's good enough. So it's the thing that's choosing, should I try and do a predicate pushdown to get Hadoop to do some of the work, or should I just grab the raw data set and pull it into SQL? Who knows how you can help control what the optimizer chooses for that? Anyone? How do you help the optimizer regardless in SQL? Sorry? Evil, that's the last choice. Before query hints. Sorry? Even simpler than indexes. How does the optimizer know about the shape of a table? Yay, stats. So yes, you can put stats on external tables. So yes, that will help the optimizer know about the size and shape of your external data as well. So, right, that's my rah-rah. Okay, let's have a look at Polybase. Put my glasses on so I can actually see. So, this is my little demo environment. So I fired it up in Azure and had a couple of VMs. One's my SQL one, and one's a box running Linux with Hortonworks Sandbox on it, which I know very little about. So there is a beautiful demo template if you're interested in finding out more about Hortonworks as well, that you can get out of the Azure gallery, build a sandbox, and then follow through the guides. And it's really great. So just to show what we're on for our SQL box, this is a SQL 16 box, and everyone knows that CU2 is out, and you should always apply the latest CU. Just smile and wave. So that's where we are. So let's just get rid of that because it's in the way. Okay, so first off, we actually have a little option. So by default, even when you get the Polybase working, to be able to write out to your external data source, that's blocked by default. So you do have to actually set this SP-configure option before it will let you actually do any inserts or writes out to the external table, which is an interesting choice. I'm not quite sure why they did it that way. So first step, we've got this create external data source. So you can tell the F is for Friday because I ran the T yesterday to make sure it worked. Thank you, Pat. And just saying this is Hadoop, and location is the internal IP address of my sandbox. Just so you know, if you're running Polybase, then Hadoop is the only option on here. But if you look in the documentation, Azure SQL DB uses create external table for its elastic queries and one other thing. And so there are actually other options on that type, but they're completely different to Polybase. So we did it just to confuse you. So even if you're going to Azure Blob Storage, you still put Hadoop in that type. So Control R works again, which is cool. And then we've got the create external form file format, and we're just doing these things. So lift that out. Oops. F won't do. And there's a couple of DMVs. What did F do? Oh, that's find. That's why. So yeah, you can pull out all the info from those DMVs. And if you're wondering why I'm not pressing F5, it's because I've got a silly keyboard that has IntelliSense function keys, which automatically take them away from being function keys. Sorry? Control what, sorry? Ah, okay. Learn something new every day. Okay, and this sample 7 is a table that comes straight out of the Hortonworks demo stuff. So I'm very keen on using other people's work rather than reinventing the wheel. So here we're just saying, let's create an external table, give it a location, so it's down in the bowels of the HDFS file store. Data source is the one we've just created. The file format's the one we've just created. So hopefully it works. Yay! And then you can see off in our Polybase database, we've got a new tab called External Tables. So you've got all the external tables, including the one I just created for Friday. And it doesn't have any stats because I didn't create any. And then, as long as it works, we pull out the records from the Hadoop data store. And just hopefully to show that we're not cheating, this is a GUI interface into the Hadoop data store, and it lets you do a SQL-looking query into it, so you don't have to write Hive or Pig or any of those sort of other things that people love. Woo, come back. And we've got another bunch of stuff. So just to show that I'm not really just cheating and having a SQL database at the back end. So that's pulling the stuff out. And I've just got another table, and there's multiple formats inside Hadoop. So there's the TSV and CSV, and there's awk. And no, I don't know the details of what those all are, but you can quite happily specify those. Whoa, I didn't change that one to an F. And I did change that one though. Completely inconsistent human. And the other interesting thing is that you can create multiple external tables on the same location here as well. So I think I've got mileage F, mileage T, and mileage something else that are all pointing to the same underlying Hadoop structure as well. So it doesn't stop you doing that. And again, we can pull out of it. Woo, don't do that. Pull that out of there. So, and that's all the stuff I ran to do testing. So, woo, come here. So this is doing the same thing and just saying that you do actually see the operation show up in your query plan and just shows up as a remote query. And you can see that this did a horrible estimate for the number of rows. So it thought there were 30, because I haven't actually built any stats on this thing, and it had 800 come back. Now there is an option that you can use as a query hint, even though we don't like query hints. But you'll see if I try and use it here, this is trying to say please force predicate pushdown, even though it's such a small data set it doesn't matter. But what you do need to have for predicate pushdown to work to Hadoop is either you've got Kerberos sorted out on your Hadoop environment, which I don't know how to do, so I didn't, or there's some workarounds to give the default SQL user, which is called PDW user, God rights on your Hadoop environment. So that's why that's not working for me. And there are some pieces of documentation out there on the blog about how to do that, but it relies on knowing how to drive down inside the Linux environment that Hortonworks is sitting on to make it all work. And I'm still working on that. So just be aware of that predicate pushdown, you can test it with this option to see whether it's actually working or not. And Polybase Interact, this one. Let's go up. So if you look through the Hortonworks lab, it gets you to do a group by thing, but just saying that we can quite happily just do all the things that we normally do in SQL to do group bys, anything else that you want. And if we want to, we can, and obviously you can do create stats on that stuff. So that's our external table. And if we do actually do that, where's our include actuals? Hey. I think I turned it off. Sorry guys, the joys of toggling. And hopefully we should see that it knew that there were going to be 1 rows coming out of that, because we built the stats, and the histogram knows that there's one truck with A22 as its ID in that external table that we're querying. So that can be helpful. And if you want, you can then also pull the data in and actually persist that inside SQL Server, because obviously you've got to make a choice for performance about, are you infrequently querying the external data, in which case you probably want to leave it out on the external data store, or is this something that you're coming back to really frequently and you want to then pull that in and then let SQL be able to use all the goodness to actually make that perform better. So there's no right way, it comes down to what your use case is for how often are you going to be querying this stuff. So you can do it either way. And just to mention it, not on SQL Server box product, but in the SQL Data Warehouse in Azure and the PDW, you get a CTAS structure, which is what they were talking about yesterday in the Azure DW thing, where you can actually just do a create table as select from, and it will do all of that stuff and actually goes out and shards out all of the work as well. So it's really, really fast if you've got one of those 2 implementations. And just the trivial example of our friend sample 07 is, that's not the F1 that I created, but that's the external table, and we can just, assuming that we've turned on that configuration item to let us write to those external tables, just throw stuff out into there, and I should be able to go into here, and we get that pop up in the Hortonworks view of the world. So just to show that I'm not really cheating, not writing out to the null device. So that's, if I minimize that, and then I can get back to my next one. So that's Polybase. And any questions about Polybase? People happy? Useful? Oh. No, if it's not on the, sorry, the question was, can it update the couch database? No. So if it's on the list, then you're good. If it's not, you're not. It possibly, and remember there's the difference between supported and works as well. So that list from the URL is the list of external data sources that are supported by this. So you may find that something else works, and there's various other people who've gone and said, hey, version 2.71 works and whatever, but it's not on the supported list. So yeah, that URL's got the full list of all the external sources that are supported for connection through this. Yep.
Just to clarify, if you had a million record table,
Yep.
no stats,
Yep.
it's not going to work, right?
It will use its base assumptions as to which way it should write the query plan for that. And it'll probably say, it's a little table, so I'll go and pull it all back. So, and it depends what your bandwidth looks like between the two systems. If you're on an APS and you've got 56 gig interlink between the two systems, then you're good. So, other places maybe not so much. So, but as always, test it out with your configuration and see what the best way of doing things are for you. So, and again, this stuff, oh. No, hasn't got a clue. Yep.
Do transactions work with this kind of external data?
I don't believe so, because I haven't seen a transaction log on an HDFS data store. So yeah, I was thinking about that one, but I believe that if you have a crash halfway through your writing data to your HDFS, then you would have to do whatever you do in that data store to clean things up and get them back to being consistent. But there's no, I haven't seen anything about DTC or anything like that in conjunction with an external data source like that. Okay? So that was Polybase. So JSON is our next off the rank. And I forgot to press the timer button, but never mind. Okay, why do we want JSON in SQL? Because it's evil and only developers use JSON. Unfortunately, Azure uses JSON horribly about DSC, all sorts of things use it. So the idea is we've got JSON and we want to be able to pull it in and actually do some work with it and possibly write stuff out of our config tables that we've got stored in SQL, because you always use SQL to manage your persistent metadata. You don't keep it in JSON files. And talk to various applications and web services and all those other things that know and love JSON. So what we've got in SQL 16, so you've got a bunch of built-in functions that allow you to actually work directly on your JSON data. So you've got isJSON, which is a simple test to say, please look at the string and tell me whether you think it's a valid piece of JSON. Then we've got isJSONValue and JSONQuery, both of which do pretty much the same job. The only difference is value works when the thing that you're asking for is a single value out of your JSON object. Query works if the thing that you're pulling back is an object or an array. You may ask, why didn't they actually write it smartly so that the thing could work out what the thing was that was coming back? I don't know. It would be nice. And then JSON modify says, I'd like to actually update the thing directly in the JSON string that I'm working with. So those all work just on the JSON object itself. Then, of course, we want to pull the JSON into SQL, because everyone wants everything in SQL. So OpenJSON is the thing that does that for us. So it'll transform your JSON object into a table. And then when you want to finish the loop off, you've then got a for JSON syntax that will actually do that and dump it through. So very similar to for XML for people who've used that. So just the examples. This is the OpenJSON. So this is the bit, remember, that does the pull JSON, stick it into a table. So we've got our JSON input. We do a select star. We throw into the OpenJSON what the JSON is and put a root on for that, and then describe what we want to pull out of that object So the usual things that we do with defining a table, and then there's the JSON notation for pulling things out of the hierarchy in there. So people here know how to sort of drill down to the JSON hierarchies? Yes, no, lots of people? Okay, you probably know more than me then. So, because like I said, I'm sort of coming at this from a SQL person looking at how we can interact with these things. So that pulls out those various things like the number, the date, and you can see that you can drill down into various bits of the hierarchy and then turn that into just a single level record inside SQL. So for JSON is the other way around. So behaves very much like for XML. The main thing to note here is you can see on the price and the quantity, you can actually put a multi-level hierarchy as in there, and that will turn it into your, well, it unflattens it, turns it into hierarchical. So you get the, where is it? The item, you can see in there, you've got item, and then under that you've got two sub-items. So you can turn that into that whole hierarchical representation in JSON if you need to. And then we've just got those three that we talked about, where is JSON, just simple yes, no. JSON value says let's go and grab one scalar value out, and JSON query where you're looking at an array of things coming out. So under the covers is storage, so there is no JSON data type, so it's not like XML. You don't create an XML column. You just throw this into an env-var as wide as you want it to be and put your JSON straight into there. And it works with collations, so if your collation says case insensitive, then the stuff will respect that, so we'll have case insensitive matches when you're going through the JSON stuff. So that's useful to have. So if you're trying to do indexes, again, there's no JSON type, so there's no JSON indexes, but it is just a varchar, so you can do things like use your JSON value and JSON query, and then do a computed column and index that to be able to index into specific pieces of your JSON, so quite flexible like that. And if you want, you can do full text search on it as well. So because it's just a string, you can use all of those standard methods that you've got available for strings in SQL to speed up your queries on those JSON objects. And the other cool thing is that because it's just an env-var, you can throw it into anything that works with env-var. So if you're using Hekaton in-memory technology, you can throw it straight into there as well, and it'll just work with that because it's not a different type. And you can throw it into column store as well. And column store compression will look intelligently at that JSON and try and look at the size and shape of that. If it's a really big hunk of JSON, it'll say I'll do compression on that individual value. If it's lots of little bits, then it'll do aggregated compression on that stuff and get your size down and let you do segment elimination and all of the other good things that column store does for you. And for your client drivers, again, it's just an env-var, so you don't have to worry about whether your client drivers will know about this new thing that you're putting things into. So beautiful fade. So go and play with JSON a wee bit. That's the R1, which is the wrong one. This one. And JSON inbound first. Okay, so I've just got a env-var that I've thrown a hunk of sample JSON into, which if you go and look at the Books Online documentation, you may recognize. So we can declare that, and we can quite happily just do a isJSON test on that, and it is, which is quite useful for the rest of the queries. So again, we've just done a JSON query on the first object inside this JSON array, which happens to be there's an order there, which is order 659. So that's pulled that out as a thing from query, and then value, we've said we want to go down and drill down into the individual account number inside there, and that's just pulling that out as a single value. And just to show you, if I change that to query, and I'll have to do the whole lot because I didn't do that. So you can see that because it's not a object or array, then it says, no, even though I know that there's a singleton value there, I'm not going to return it to you. So just be careful of that. And if you're playing with this stuff, one thing, it's not just SQL 16, but it's compatibility 130 as well. So if you leave your compat down at 120, all of this stuff will give you formatting errors and fail miserably. So be aware of that. So again, we've just got our same hunk of JSON there. And this is just showing you the open JSON stuff. So if you do this, we just pull out the two objects there. We haven't done any specific formatting, so it says I've just got some fairly useless things in my table. So what you really want to do most times is actually, now have I got that turned on or off? I think that's on. Any takers? I think it's on. We'll see. Is actually use the with clause on there to specify which objects you want out and name them out. So when we execute that, it actually gives you something slightly more useful in terms of data that you can use. And then again, you can see this turns up as a table valued function for what it's doing inside your query plan. So that's that one, that's the first. And just to play around, this is inspired by Dandy. I went and grabbed a data set of JSON from the New York 311 data set because it looks nice and it's slightly bigger. So we can throw that into is JSON and know that it really is JSON. And just pull out our various bits of JSON data from there. Let's see if I can remember where the comment, yay. And then we can throw that out. So that was, sorry, I'll just try that again, just so you can see the first one. So again, if you just do a straight open JSON, all you get out of this is 2 rows. And again, not particularly useful because this one has metadata and then it's got all the data, which is a squillion rows. But just the default behavior does things that may not be particularly useful for you. And then again, we're just pulling out that and gives you slightly more useful view of the world. And then just the outbound. So we're looking to try and take stuff out of a table and turn it into a JSON format. So we've got our friend AdventureWorks, which I know has been replaced by worldwide importers, but the sample I had was for this. So you've got a table, use the for JSON auto on that, and if we take that and put it into Visual Studio, into a JSON file that I cunningly created earlier, you can do format document on that and it will lay it all out for you. Can't do it in Management Studio yet. But yeah, Visual Studio is a cool way of doing that. So it shows you all the sample of that stuff. JSON. And And if we want to, we can put JSON path on there. By default, this for JSON path will not put null values out. So you'll get sort of a ragged data set in the JSON representation of this stuff. If you do want to see the nulls in there, so you get 10 key values in every JSON thing that you've got there, you can include null values there, and you can include a root description as well. And again, we can just grab that. And there's just this format document option that will lay all that out nicely in a readable format for you. So, JSON. So, that's the end of the demo stuff for that. So, JSON, people happy with that? Yep. Any questions? Anyone going to complain about not being a JSON data type? Not that I've heard of, no. Just upgrade, feel the love. Sorry? I'm not a licensing expert. I haven't seen any internal stuff, and even if I had seen internal stuff, I wouldn't be able to tell you. But the reasoning I've seen on the blogs is that you've got all these other bits of infrastructure like Hackathon, CCIs, all the client drivers and that. And if you're bringing in another data type, then you would potentially have to go away and try and get all of those compatible, and you would slow down adoption. So it's sort of a low-touch way of making it goodness for people. And you've got all the ability to create a computed column, index that, stick it into a column store. So there's quite a few options that are there available. And bear in mind that all of these options are not about doing super heavy lifting and replacing your existing thing that you're doing primarily JSON or other non-SQL things with. These are about hybrid implementations to say I've got some SQL stuff and I need to do some coexistence with other ways of doing things like JSON, and how can we make it easier for the two to live side by side. If you've got primarily a JSON workload, then you use whatever tool you use for JSON, document DB or whatever it happens to be. So it's not about the crushing the rebellion with one swift strike. It's coexistence and getting along with everyone else nicely. So that's JSON. So the next one is our friend R, which looks silly written on a slide like that. But that's the standard format. And it makes it hell on earth when you're ever trying to do a interweb search. Find me stuff about R. Okay, so a beautiful slide that someone in marketing built. So anyone not know what R is? Yeah, a few people. So we actually started out in Auckland University a long time ago, sort of sometime in the 90s. Some guys got together and wanted to replace the S language. So they called it R. Because you go backwards, because C replaced B. So language platform, it's really aimed at doing analytics, big number crunching, all of those sorts of things that statisticians get excited about, and doing chi-squared tests and all those other things. And it's an open source package, so you can go away and just grab it and use it gratis. So there's lots and lots of people using it. And it replaced things like Minitab, if anyone was old enough to use Minitab. Did someone knew Minitab? Yay. So there's lots of people using it, and there's a bucket load of freely available downloadable packages for it. So 7,000 it says there. So pretty much anything common that you want to do in stats, you can go and grab a thing from the library and avoid writing it yourself, which is always goodness. And if you went along to the Jennifer, I talk at 1,000,000 miles an hour talk, then it's used by the data scientists heaps in things like machine learning. So you can just grab the open implementation of R and run it yourself. So the goodness of integration into SQL Server is that you can just do all of your modeling and deploying in SQL if you want to. So rather than switching platforms, you can do all these things and have your complete life cycle. And one of the other good things, obviously, are typically you're running on quite big data sets. So if you just install it on your laptop, you then, if you're just running it that way, pull all the data down out of your SQL database, run the algorithms against that, and then potentially ship the results back up. So the idea of this is that instead of taking the data to the code, you take the code to the data and run it on the SQL Server. And it can interact with your SQL tables that way. And the implementation in SQL also lets you use the SMP parallel performance as well, obviously driven by the optimizer. So it means that potentially you can get better throughput on your R queries as well. Take advantage of the big box that you've got sitting there for SQL to run with. So actually under the covers to install it, just another option on the installer. That's the screenshot for the GUI. Of course, you all do scripted installs and have it repeatable. Yes, you do. Just be aware that if you do use the command line installer, there is a new I accept option for this because it goes away and installs Microsoft R open on your SQL box. You have to accept the open license terms as well as the Microsoft open terms. So another thing to be aware of. And there is another SP configure option to let you start running these things. You need to set that on to 1 to turn it on. And that one's just a Boolean, simple 0 or 1. New things that turn up. So there is a service that you will see called Launchpad Service. That's part of the configuration and handshaking stuff. I happen to have 2 instances when I took the screenshot, which is why you've got R2. And I forgot to put D2 on the end of it to make the joke, but never mind. And there's another group that turns up in your local users and groups called the SQL R user group, which is not a bunch of people getting together to eat pizza, but it's just some accounts that get set up in your local machine for R to be able to fire things up. And by default, it creates 20 users on there. And there's also a new security thing. So if you want to grant people who are not sysadmin the ability to run your scripts, then there's grant execute any external script. And obviously you can then narrow that down to specific scripts if you really want to. But those are the main things to be aware of. The Launchpad one is interesting for people who sort of go look at your services and go, what's this new thing that's popped up? Because it doesn't, from the name, relate to anything SQL-y. You're going, has some virus come along and leapt onto it? And just to highlight another beautiful buildy slide, that when it's actually running R from within SQL, it's actually firing off through the DLLs. So Revolution R Open, I think the RRR stands for. So it's firing the stuff off through DLLs and then coming back into SQL Server. So you do actually have R installed on the SQL machine and you are making use of the DLLs that are in there. So once you've got it installed and all configured, this is how you actually run R inside T SQL. So simple call to SP execute external script, just rolls off the tongue. Language is R, and that's the only option. So future-proofing it so they can put S in there as well. So that second line, the script, is the R, and that's one of the simplest R scripts you can write. So it just says, take the input and put it into the output. Hopefully your R is slightly more complex than that. And then you can feed some data into it. So here we've done the ever popular select from sys databases and throw it out. So that's it for running your R. And of course you can put all that code into a stored proc as well. So it can be called from anywhere you want. So usually people want to develop and not be running on production when they're doing their development work, so you can run R from Visual Studio as well. There's lots of other IDEs as well, but Visual Studio is the Microsoft one, but choose your own. So here, again, we're just setting up a data source with that line up the top to my local host. Slightly different syntax here, but not very much. So you just have a query where you define, again, sys databases, and then do the work to say I want to run my query and throw it out to the data set, and then head is print out my data set. Again, a really trivial piece of R code, and you can just run that. So we'll have a quick play with R. And I will just get rid of my JSON. So I was tempted to build 3 virtual machines so that I would have 3 clean environments to do the different demos on, but I thought I might get told off for spending too much money of my Azure credit. T SQL. So this is just the really basic. We're in Visual Studio. We want to run some Control Enter. We want to run a little bit of R on SQL, and just to show you that it really does work and pulls out our various stuff from sys databases. So that's that one. And I stole some of this code from a demo that's on GitHub about fraud detection. So just to say that you can have a more complex piece of R. And again, we're just going up to a database that's sitting on our local host. And we can just quite happily run that. And it's gone away and done that. So that's, I think I have to actually select the whole thing. Yeah, we get a warning message because I've run it before. Excuse me. So yeah, slightly different in Visual Studio, that you have to actually do things like select the code rather than run the thing and it knows that you want to run the whole script. So yeah. So that's going from Visual Studio. So the idea is then, when you actually want to deploy that stuff, so your developer has finished mucking around, writing some defects, you know, that's what developers do. Keep themselves employed. Okay. Now, where is our stored procs? Let me just make sure that that refreshes. Right. So that R that we ran from Visual Studio did actually create a bunch of these tables, but just from productionization, because we always modify our stored procs in production. So here you can see the sort of structure that you've got, that you've just got a stored proc, and whoever wrote this is hideous because they're truncating a permanent table and then doing an insert into it. So don't do that yourselves. So here we're just doing an execute of the external script and a whole bunch of R code. So you can quite happily do that, and you're just pulling it in with pretty minimal change from your Visual Studio environment. Daniel will tell me off, of course, because there's no automated deployment being shown here. No DevOps love. So we can do that, and if we really want, we can see that in here, this one actually calls the predict R stored proc, and if we go across, so you can see the R that this stuff does is, once it goes through all the preparation stuff, it's pretty trivial, and the heart of it actually calling this rxpredict thing that comes out of your libraries. So it's not like it's writing a huge amount of maths code inside your stored proc. most of the time people are just calling existing methods from libraries. So that is that one. Now, let's just get rid of that. And so the idea is, because there's a bigger demo that wraps around all of this and use Power BI and all that sort of jazz, but we like command line. So the idea is that you have R and it goes through all of your transactions and scores them for likelihood of future transactions being fraudulent or not. And then you've got a piece of R that goes through that, uses the predictive model, and says, this is the scoring stored proc, feed it into stuff that comes in from a website, and we can quite happily get a score to say, what's the likelihood that this thing is going to be a fraudulent transaction? So you've got this thing on account 920. Do the same thing with a slightly different account, and hopefully you get a different number. And so the idea is here, we've just got a pretend website where you can buy things. And, ooh, that's what I forgot to do. Let's start our trace. And just try that again. Oops. Let me just reset that. Yay. So it tells me there's a problem because someone down in Wellington will get upset if I try and buy diamond engagement rings, because I don't think I need one. And that's firing off our request to go and score that thing, which then in turn fire off our R prediction, which then sends a piece back to the website to say, oi, I think you better get this person to ring in before we authorize their transaction. Okay, so, and yes, I should have used extended events and not used profiler, but never mind. I'll nag myself. So there ends the demo for R. So sort of quick overview. So R is really complex language, or potentially complex, but really powerful. So the idea is T SQL is good at record sets, manipulating big hunks of records, aggregating those sorts of things, but R is really good at doing stats and all of those complex calculations type of stuff. So you can quite happily use it in conjunction with your SQL to mix and match and keep people happy. So that's the end of me talking. So questions about R? No, you're all stunned silence. So we will nag you to do the evaluation, and last chance to do this. There might be a few less people here today, so your chances of winning possibly go up slightly. And so thank you, guys.